There's a square, ABCD, sideline is 1. So let's go kind of start with that. And this E and EF are on the side AB and CB. So maybe we should label those. So I'll say this is A, B, C, and D. Okay. And such that E is on side AB. So let's say E is somewhere right here. And we can change its place as we need. And F is CB, so it's gonna be somewhere right here. And then AE and CF are equal. So this piece and this piece is equal. And when the square is folded along the line DE and DF, so this is DE and this is EF. And these two lines will coincide and lie on the diagonal BD. Okay, so that is this one. So when you like folding this one, if you're getting this like point A somewhere on this diagonal through this line, so maybe we should see that as well. So if you draw this, and the same thing with DF. So when you fold this over this DE, and then if this part is kind of getting on this line, same as point F, so A and F will coincide. And we want to find the AE based on this. Like if you do that, like you need to make sure that the E and F, since they are going to coincide, so when you connect that segment, that should be perpendicular to the line of symmetry, because BD will be our like line of symmetry, because that's what we're using for line to fold it. So which is why this piece and this piece will be equal, and then this guy and this guy will be equal, because this DF will coincide like this one. So that is isosceles triangle. And what we also know, one side was 1, so this is also 1. And since we are looking for the AE, I'm going to label that is X, and then that will be X. But at the same time, we are taking this DF and folding this C over this one to get this point, right? So which means C is going to be getting right here. So I'm going to call that's like C prime, meaning that this X and this segment actually the same. So which is why, even though I use different notation, like different symbol to say, but we see they are equal, so we can change it at this point. But at the beginning, I didn't mark the same, but I do now. So this guy and this guy is equal. So the same reasoning, this is also the X. And we also know we are taking this folding, right? So, and then we know this is 45 degrees. So since this is 90, this is going to be 45. So which is why this is also X. So we have a nice 45, 45. So that's X root 2. And one side became X root 2 plus X. So, and then that's equal to 1. So I can just say X plus X root 2 is 1. And then I like to X alone. So that could be written like 1 plus root 2 is 1. And then X should be 1 over 1 plus root 2. And I can multiply this by 1 minus root 2. And then that's going to be 1 minus root 2. So 1 minus root 2 over. This is difference side square, which is 1 minus -2, 1 minus 2. That's -1 if you divide this by -1. So you end up getting root 2 minus 1, which is the form that we are interested, which is good. So, and then K is 2, M is 1. So we are adding those two numbers, which is just 3. So even though this is number 8, and this wasn't too challenging, but the folding problems are really common. So this was number 8. Okay, I'll see you next week.